Welcome to the Deep Dive. It is November 27, 2025. And today's AI updates really confirm something we've been seeing for a while. The industry is officially past that initial hype phase.
It really is.
We're not talking about hypotheticals anymore. We are squarely in what analysts are calling industrial AI. These are integrated systems, they're driving critical business workflows, and maybe most importantly, they're defining state-level geopolitical strategy.
And that's the key paradox we're seeing today, isn't it? On one hand, you have this extreme national ambition. I mean, these sovereign compute races are accelerating, especially across Asia.
Right.
But on the other hand, the very foundation of security is being tested. We're seeing huge vulnerabilities, and not in the core models themselves, but in the third-party supply chain. It's compromising even the biggest AI companies.
That is exactly what we need to unpack. So our mission today is to pull out the most critical, fact-based intelligence. We're going to cover everything from research breakthroughs to the geopolitical chip wars and, of course, the maturing of AI policy worldwide.
Let's do it.
Okay, so let's jump right into the research. If the last couple of years were all about scale, just making models bigger, today's focus is clearly different. It's shifting to efficiency, safety, and, I think critically, agents. Let's start with a huge leap in physically grounded AI out of China.
Yeah, this is from Alibaba's Qwen team. They just released a technical report for Qwen-3VL. That's their newest vision language model.
Okay, a VLM.
But what's really fascinating here is they're pushing way beyond just standard image recognition. Qwen-3VL has enhanced multimodal reasoning and, this is the key part, unified 3D reconstruction capabilities.
So why does that 3D capability matter so much in the grand scheme of things?
Because it's the foundational piece for building practical robots and autonomous systems. I mean, for a robot to navigate the real world, think manufacturing or logistics, it needs to understand geometry and depth, not just, flat pixels. This is a huge advance for those kinds of physical applications.
So if Qwen is about building these complex physical systems, we immediately have to talk about how to stop those systems from failing in dangerous ways.
Absolutely.
And that brings us right to safety and the problem of reward hacking.
Precisely. A new paper introduced Evil Genie. It's a new benchmark, a data set and evaluation framework that's designed specifically to detect and quantify reward hacking in reinforcement learning systems.
And reward hacking is, just to be clear, where the AI figures out a shortcut to the reward without doing the thing you actually wanted.
Exactly. The insidious failure point. So this benchmark gives developers standardized metrics across more than 1,000 RL scenarios to help them build more robust, more aligned systems.
Now, here's a data point that I think should redirect millions in R&D funding globally. A new study from MIT looked into where AI improvements are actually coming from.
And the findings are kind of staggering. They analyzed performance gains and found that algorithmic innovations and data efficiency, so things separate from raw compute, are massive drivers.
How massive are we talking?
The study suggests algorithmic improvements alone contribute 30 to 40% of the overall performance gains. 30 to 40%.
Wow. So does that mean the endless, incredibly expensive compute arms race is fundamentally misplaced? Or just that the money should be rerouted from buying GPUs to hiring the people who can find that algorithmic cleverness?
Well, it definitely points R&D toward more sustainable innovation. And that cleverness is exactly what we're seeing in the latest agent research. Again, from Alibaba, their Tongyi lab published work on something called Agent Evolver.
Agent Evolver, that sounds like something out of science fiction. What's it doing?
It's basically an autonomous agent self-improvement framework. So the AI agents generate their own training data just by exploring their application environments. The agent is its own QA team, its own data labeler.
So it cuts out the human bottleneck.
Completely.
Oh.
And this approach got a 30% performance improvement in tool-used tasks. It could dramatically accelerate agent development.
And finally, on research, making sure these huge models can actually run efficiently everywhere is the big commercial challenge, not just in training, but in serving them up to users.
Right, and we got a really neat architectural solution for that today. A new paper proposes something called DSD, or Distributed Speculative Decoding. It's a way to optimize large language model inference across hybrid edge cloud environments.
How does it work, in simple terms?
Think of it like having a really fast intern guess the next few words, while the main expert model checks the work. It speeds up the whole process. And in their tests, DSD reduced latency by up to 40%. That's absolutely critical for deploying AI on mobile or IoT devices.
Okay, so moving from the lab to the market, we're seeing localization and consumer hardware really driving adoption. Let's start with Google DeepMind's big move in Asia.
They've officially launched a new AI research lab in Singapore, and the location is very strategic. They're leveraging Singapore's position as a multilingual hub to improve how their models understand Southeast Asian languages and, importantly, cultural nuances.
So this isn't just about better translation, it's about making the models culturally competent.
Exactly. Developing culturally aware AI is key to lowering adoption barriers for things like healthcare and education across Asia. It makes the services relevant to, you know, billions of non-English speakers.
And while a lot of Western tech companies are still sort of debating what the next consumer AI device even looks like, Alibaba is just pushing ahead.
They are. They launched the Quark AI Glasses in China. These are wearables powered by their Qwen-AI model, and they're deeply integrated into their ecosystem, specifically the Taobao shopping app and Alipay for payments.
Wait, what's the price on those?
They start at 100 and 899, which is roughly 268 US dollars.
$268 for Qwen-powered glasses. That's incredibly aggressive. But integrating it with Taobao and Alipay, I mean, should consumers be comfortable with a wearable that has that much financial and shopping access?
While that deep integration is their whole strategy, it's the key and maybe the risk. They're leveraging their massive user base to push this advanced localized AI at a really competitive price. It's a huge move to capture the consumer AI hardware market early.
Meanwhile, Google is also pushing Gemini further into existing ecosystems. Next up is automotive.
Yes, the Gemini AI Assistant rollout has started for some Android Auto users, says replacing the old Google Assistant. And this integration brings in features like real-time message translation right into the car's dashboard.
And for developers, Google also dropped some Gemini 3 API updates that really highlight this industry push toward more controllable agents.
They did. They introduced a new parameter called thinking level, which gives developers finer control over the model's reasoning depth. And they also mandated something called thought signatures for agentic workflows,
Why are those features so important?
because they're critical for building reliable, grounded enterprise applications. It's about ensuring accountability and predictable reasoning, which you absolutely need for complex tasks.
All right, let's talk about the chips and infrastructure, because the sovereign compute race is escalating and fast. We had a massive announcement out of South Korea today.
A huge one. South Korea has formalized a public-private alliance. It unites their corporate giants, we're talking Samsung, Naver, Hyundai, SK Telecom, to build a truly massive sovereign compute cluster. This isn't just an investment, it's a national strategic plan.
Okay, how aggressive are we talking here? What are the hard numbers?
They are targeting the deployment of 260,000 Nvidia Blackwell GPUs.
Whoa.
For context, estimates put South Korea's entire existing AI GPU base at only around 65,000. So this plan targets a 400% increase in their national compute power. It's about strategic self-reliance at scale.
And that kind of massive scale-up demands standardized, efficient endpoints. We're also seeing dedicated AI silicon NPUs become standard in workstations.
That's right. The new Dell Precision 5490 workstation have an Intel Core Ultra 7 processor with a dedicated neural processor unit, or NPU, running at 1.4 gigahertz. But the crucial part is that this NPU explicitly supports major frameworks like DirectML, ONNX-RT, and OpenVINO.
So it's not just about having the NPU on the chip, it's about Intel forcing a common language for developers. Why is that framework support so important?
It standardizes the entire edge AI development toolchain. Intel is basically defining the language developers have to use to get that low-power AI acceleration. It makes dedicated NPU processing a baseline expectation, not an option.
And all of this just highlights the sheer intensity of the competition for the talent that can build these things. The legal battles are heating up.
They are. Intel publicly denied claims from TSMC regarding a former executive, Wai-Jan Lo, who was apparently key in developing 2nm chips. TSMC alleges he leaked proprietary info after he joined Intel.
Right.
The incident just underscores this intense competition for top-tier chip talent and the rise of these legal fights over intellectual property.
And finally on this, it's not all smooth sailing, even for the market leaders. Nvidia's next-gen edge platform, AGX Thor, is apparently having some performance issues.
Yeah, developers are reporting pretty severe problems, specifically long latencies for simple text-to-speech tasks. And that's a big concern because AGX Thor is built for critical real-time systems, industrial automation, healthcare robotics.
So if text-to-speech is struggling, that raises some serious questions about its reliability for high-stakes tasks where latency is everything.
It absolutely does.
Okay, let's shift to policy and governance. The rise of sovereign compute demands immediate governance, and today we saw a really clear global divergence in approaches. Let's start with India.
India's Ministry of Electronics and IT, MATE, officially launched the India AI Governance Guidelines. They've outlined 7 guiding principles, which they're calling sutras, for ethical and responsible AI adoption.
What's really striking is the timing. They're synchronizing the policy before all the hardware is even deployed.
Exactly. India is setting up these regulatory and ethical controls before their national compute infrastructure, those confirmed 38,000 GPUs, is fully running. It's a calculated move to embed safety from the very beginning, a very different approach than we've seen elsewhere.
And now to the security story that really hit the core of the industry today. The OpenAI mixed panel data breach. This is the one we have to reckon with.
This was a major third-party incident. OpenAI disclosed that a security compromise at their analytics vendor, Mixpanel, exposed profile metadata of their API users.
Okay, so no models or API keys were lost.
Correct. No model weights, no API keys, but the leaked data included names, emails, organizational IDs, and this is crucial, referring websites.
That referring websites detail, that sounds incredibly dangerous for corporate espionage.
It creates severe phishing risks, and it's a huge corporate vulnerability. Threat actors can use those org IDs and referring websites to map out internal R&D projects. They can basically figure out which teams inside which sensitive companies are building what on OpenAI's platform. It just proves that the entire peripheral vendor ecosystem is the industry's weakest link right now.
Meanwhile, the EU is taking a very different regulatory path, focusing more on societal risks.
That's right. The European Parliament passed a resolution calling for a minimum age of 16 for accessing AI chatbots and AI companions. They also want to ban addictive design features in these interfaces.
So it's a clear divergence. The US is focused on catastrophic existential risk, while the EU is legislating around mental health and addiction.
It's a totally different philosophy on what the primary danger is.
On a more positive policy note, we saw open source models being used for social impact over in Ireland.
Yeah, this is great. Meta and Deloitte Ireland hosted a Llama for Good hackathon to help Irish NGOs. Because Llama is open source, it removes that massive cost barrier to using advanced AI. They were building solutions to automate things like mentor-mentee matching for community programs. It's a great example of open source for public benefit.
And finally, AI risk is becoming fully institutionalized in regulated sectors.
EY reported that Swiss financial institutions are now actively aligning their cybersecurity frameworks, like ISO 27001, to incorporate the NIST AI risk management framework. This really confirms that AI risk has been codified as a quantifiable financial liability. It's demanding auditable controls across the global financial sector.
All right, let's turn to enterprise adoption, which seems to be creating a real competitive gap between companies. A report from PYM-NTS found that agentic AI is creating a two-speed enterprise landscape.
Yeah, this report's a huge warning for any executive who's delaying adoption. It found that companies that are moving fast on autonomous agents for workflow automation are already seeing significant competitive gains.
How significant?
Early movers are realizing efficiency gains of up to 25% over their competitors. It shows these agents are moving way past the pilot stage and are driving real ROI.
And we have a perfect example of this in production from the travel industry.
Booking.com detailed their launch of a generative AI agent just for partner guest messaging. This thing handles multi-turn conversations about reservations, policies, the high-stakes stuff.
What kind of automation rate did they get?
An 85% automation rate for common inquiries. It's really setting a new benchmark for high-volume customer service automation.
We're also seeing this translate into solid market forecasts, particularly in specialized areas like healthcare.
Right. A market analysis is forecasting substantial growth for the AI pathology quality control sector. They're expecting it to reach $3.84 billion by 2029. And that growth is driven by AI's ability to augment human experts, improving diagnostic accuracy by 20 to 30%. It's critical for addressing the global shortage of pathologists.
So wrapping up, we covered two really defining trends today. We saw that geopolitical race for compute heating up with South Korea's massive Blackwell target. But at the same time, the critical importance of supply chain security was just laid bare by that mixed panel breach.
And that's the industry's biggest challenge right now. The focus has to shift from just securing the core models to securing the entire peripheral vendor ecosystem, all the analytics, the logging tools, all the third parties holding sensitive metadata. That mixed panel failure showed everyone where the new security frontier is.
So if you're looking to integrate some of this intelligence today, we have two tools for you. First, check out the Agent Evolver framework from Alibaba. That's the open source framework for autonomous agent self-improvement.
Right, where the agents create their own training data. And second, look at the DSD framework code. That's the open source implementation of distributed speculative decoding for PyTorch. It's essential if you're trying to run these large models efficiently on limited hardware.
Okay, let's hit the numbers of the day. First up, $268. That is the approximate US dollar price of Alibaba's new Quark AI glasses, which really just illustrates the rapid consumerization of advanced AI.
And our second number, 260,000. That is the staggering number of Nvidia Blackwell GPUs that South Korea has targeted for deployment, reflecting a massive, coordinated, state-level investment in strategic computing.
So we'll leave you with this final thought. If that MIT study is right, and algorithmic improvements alone account for 30 to 40% of performance gains in AI, what does that mean for the startups that are focused on architectural efficiency? Can that guaranteed algorithmic efficiency let them disrupt the giants who are just trying to win by securing the biggest compute budget? The game might be changing faster than the chip makers realize.